Let's do an example of disk method when we revolve about the y-axis. If the region enclosed by the y-axis, the line y equals 2, and the curve y equals the square root of x is revolved about the y-axis, then the volume of the solid generated is what? Let's first graph all of the stuff that we have. Y equals the square root of x looks like this. Y equals 2 is the horizontal line somewhere over here. So we'll call this y equals 2. And the y-axis. So we're looking really at this area, this region inside of here. So to revolve this all around the y-axis. When we do that, let's take a look at one of our cross-sections. So here's a point on our function, and this point is going to get rotated around like this. So this will create some sort of a spinning top kind of figure in the 3D model. And of course the radius is from the y-axis to the actual function value right here. But of course that has to be in terms of y. And right now our function is in terms of x. We can change this. Y equals the square root of x. If you square both sides, we have x is equal to y squared. Oh, hey, look at that. This is the graph x is equal to y squared. So the radius is just y squared. Now let's talk about our limits of integration. We're going from y equals 0 up to y equals 2. So we can set up our integral at this point. We have the integral from 0 to 2 of the area of each of our cross sections. Now our cross sections are circles. So we have pi r squared. Our r here is y squared. It's the function value with, in terms of y. So this is y squared dy. And this is the setup for our integral. Let's actually do it. Let's pull out the pi. We've got the integral from 0 to 2 of y to the 4th dy. This is equal to pi. The antiderivative of y to the 4th is 1/5 y to the 5th, and this is from 0 to 2. Well, this is equal to pi times, if you plug 2 in, 2 to the 5th is 32, so this is 32 over 5 minus 0. And so the answer here is 32 pi over 5. That is the volume of this particular solid that we have obtained by rotating this region about the y-axis. The region R in the first quadrant is enclosed by the lines x equals 0 and y equals 5, and the graph of y equals x squared plus 1. The volume of the solid generated when R is revolved about the y-axis is what? Well, here is the region in which we are talking about right here. We're looking at this part that is bounded by y equals 5, x squared plus 1, and the x-axis. Now I've graphed the entire thing here because when we revolve this about the y-axis, turns out that the symmetry of this parabola is retained. And so we're looking at a paraboloid that looks somewhat like this. This will be kind of like a satellite dish, if you will, where the radius is the distance from the x-axis to the actual function value right here. Now, of course, we are integrating from 1 to 5 along the y-axis. However, first we have to get our function y equals x squared plus 1 in terms of y, because our cross sections are perpendicular to the y-axis. So that means that x squared is equal to y minus 1, and furthermore x is equal to plus or minus the square root of y minus 1. The question is it the positive or the negative square root? Well, it doesn't fully matter. However, we are in the first quadrant, so that does mean that we're looking at the positive square root. So there we go. So our radius here is square root of y minus 1. It's at this point that we can now set up our integral. We have the integral from y equals 1 to y equals 5 of pi r. Our r here is in terms of y, and it's the square root of y minus 1 squared dy. Well, let's make this look a bit nicer. We have pi times the integral from 1 to 5. The square root and the square cancel out, leaving us with just y minus 1 dy. So this is equal to pi. The antiderivative of y is 1/2 y squared, and the antiderivative of negative 1 is negative y. This is from 1 to 5. Let's first plug in 5. Here we have 5 squared over 2, that's 25 over 2, minus 5, minus, let's plug in 1, that would be 1/2 minus 1. 5 can be rewritten as 10 over 2, and so 25 over 2 minus 10 over 2 is 15 over 2, minus 1/2 minus 1 is negative 1/2. Now 15 over 2 plus 1/2 is 16 over 2, which is just 8 times pi. And the volume of this paraboloid is 8 pi.